Trying to bring energy.
Okay! That's how your lecture will start, by the way. This is just loud okay. All right. Today we're going to talk about this in JavaScript. The first thing is going to be answering this person's question, Dan Abramov's question. So I've already opened it for you. And this is the question. Yes, it's from Twitter. Thank God for databases. So these two snippets are different. This is finally the time we break down method and function. We have object.method, and this is being invoked. And then we have var method, assigning it the same value as object.method, and then invoking the method. So far, so good. I'm essentially creating a copy of object.method, and I'm storing it as this variable. So what is method right now? Obviously, with the band, as you can tell, it's what? It's a function. These two are different. If you learn why, you will understand JavaScript. Cool? Does anyone have any idea of what the differences are?
One is a function and the other is a method.
Surprisingly insightful. One is a function and one is a method. What does that mean? Here's
Being called on an object, and the other one's not being called on an object.
That's exactly correct. One is running as a baseless function. One is being called on an object. So if a function is being called on an object, it is known as a method. Notice how in Ruby land, in Mod 1, we always talked about, let's define this new method. Let's make a method. Let's call the method. Because everything in Ruby is an object. So anytime I call something on anything, I'm essentially calling a function on an object. If everything in Ruby is an object, everything in terms of like functioning code in Ruby has to be a method. And then we started talking in JavaScript in Mod 3, and the first thing that you got slapped with was function name bananas curly boys, right? And so that's the main difference between function and method. How we feel about that? That's going to be very klooch. Welcome. Awesome. Let's do this. Let's kind of go over it, right? First thing I want to talk about is I like to make the parallels between Ruby and JavaScript because you have that baseline. So let's review some self in Ruby. I have this class person, and inside the class person, within these lines, the main scope of everything here is the class. So if I call self anywhere here, I'm actually referring to the class person. If inside, however, if I were to make a brand new method, some method, boop, boop, inside the scope here on line 12, because this is now an instance method, inside the scope of 12, self refers to the instance. Anything inside the class, self is the class. Anything inside the instance method, self is the instance. It will adjust accordingly based on the scope. And so that is essentially the main correlation between this and self. How do we feel about self, okay? Okay. So I want to talk about something that's important. Self is not this, all right? If you take literally nothing away from this lecture, I need you to know self is not this, and I need you to be able to successfully answer this question. Those are the only two learning goals for this lecture. Cool? I say things that are kind of snarky sometimes, and one of the things that I like to say is words mean things. And so when we're talking about Ruby, we use the word self. When you talk about self, the word in English, what can it only possibly ever refer to? Yourself, right? But you are different when you're in different places, right? Like here, self, your student. But you visit mom, your lovable child can do no wrong. Your self is technically different, but does it refer to anyone different? Self is always you, but you are different based on where you are. So, in the same way, self is always referring to whatever's calling it. So, if person.new and I do Andy.name, which is a instance method, or I do Andy.some method, Andy is the one that's calling it. So some method becomes, inside of it, self becomes Andy. If I did person.saySomething, person becomes self. Whatever the object is that's calling the method, the object becomes self. So the object is calling the method, the object becomes self. The object calls the method, the object becomes self. So far, so good.
One more time.
Very good. Self becomes the object that calls the method. The easiest way to think about it is, what is to the left of the dot operator? Person is actually the object that is calling the method say something. It's receiving that message. So inside this class method, person is self. If I do Andy, which is an instance of person, calling some method, Andy is the object that calls some method, and so self will refer to Andy in this case. Right? Awesome. What about the word this? Words mean things, right? Self we've already identified. What about the word this? If I'm writing Marta and it breaks down and I'm like, man, this is awful. I'm going to eat food at the taco truck and I'm like, man, this is delicious. I'm lecturing to a group of students who love to participate and I'm like, this is amazing. What is this? It is the situation dependent, but more specifically, context dependent. And when we talk about context, specifically in the way that your code is running, when your code runs, it's being executed. So the execution context is important as it pertains to what the value of this is. Where and when I say it is going to change the definition of this. Where and when I say the word this is going to change what this means. So far, so good. Just in English, nothing code. How does that translate to code? Where and when I say this? Probably
Scope.
Yeah, scope. It probably means where I write the this keyword and when I execute it, the this keyword will change. Where I write it and when I execute. That's the main difference. With self, the only thing that's important is where I write it. No matter when I call the instance method, I can have Andy.some method anywhere in my code. Andy will always be self. Person.saySomething anywhere in my code, whenever it runs, person will always be self. The tricky part with the this keyword is when and where I write it and when and where it's executed will change. So there's a lot of things to consider, and that's why it's so tricky. Conceptually, how are we feeling about the difference between the this keyword and self? Nothing in execution. Thanks, by the way. I know that's like kind of annoying. If you just want to like nod, that'll work. Thank you. This is a GIF my friend inserted in here, and I have no idea what's in here, but I've left it to keep his legacy alive. He's not dead. That was just more like a RIP, rest in power. So this sounds very much like clickbait. There are 4 rules to learn this, right? Developers hate them. Cool, I'm gonna talk about like the 4 main rules that govern this. And so I'm actually gonna start with rule number 3. They're not in any particular order, I just never reorder them, and I always thought that was funny. I guess no one else does. So, this within a function, called within a particular context, right? Object.method, will be the context object, assuming the function was declared with the function keyword. I'm going to talk about the arrow function. All I need you to do is stay with me is in function land. Cool? We're going to talk about arrow functions later. Dog is what? An object, right? And objects can have keys. And those keys can be strings, those keys can be numbers, and they can be funcciones. How do I get to name?
Dog.
Dog.name. How do I get to this function?
Dog.
Dog dot what is this? Which looking like a Ruby, right? It's object calling the method. And this method, remember, is now a function being called an object, so I'm going to say the word method. This method, so far so good, returns what?
Dog.
Yes, and more specifically,
The whole object.
it returns this, right? All of that is correct, by the way, but I want you to look at something. If I invoke this function, it will in fact return dog, because it looks like self. It looks like a Ruby, right? Dog dot what is this? Self in this case, or this in this keyword context, will be dog. So you can in fact kind of follow the same general rule of thumb, and that is to the left of the dot operator is what this is going to be. I'd like to start with rule number 3. Sorry, I don't want to say this. I want to start with rule number 3 because the example that my hand is touching right now looks the most like Ruby and self. Should be kind of no real difference here. So far, so good. All right, it's going to scale very quickly. This is just, I don't tell you to memorize much, right? How much have I actually told you to memorize this whole time I've been lecturing you?
Nothing. Let var const, that's about it.
Maybe not memorization, but the idea is, this is one of the few things you'll actually just like come to know from memory. But is this being called on anything? No, it's not dog dot. It's not person dot. It is blank, say this. It is being executed on the window because the window really is like the browser window. And I've always said the browser runs your JavaScript. And have you watched that powerful, I'll bet a little bit slow, 3.5-hour video?
Yes.
What's the first thing that goes on the call stack? Starts with a G, ends with global. The global execution context, right? So far, so good. This right here, the global execution context, is in fact the browser. And so everything becomes stacked on top of it until the call stack is clear, which means that this has everything in scope. This is the browser running your code. This would be the window object. So you can think of it as this hidden version of window.sayThis in a way. In the same way that, remember where I said, where did fetch come from? It's a function, right? We talked about the document, and we took a look at all the properties. I'm sorry, document is just HTML, embarrassing. I lost it. I'll get it back. We talked about the window object, right? And look at everything that allows you to do. Debugger comes from the browser. We looked at a couple other things that are important. Notice how when I called fetch, it just said, oh, yeah, that's a function that exists. It's technically part of the window. So when I have what is known as a baseless function, to the left of it is the global execution context, which you can think of as, that was bad, I'm sorry, the window. How we feel, right? That's not a bad explanation. So we've got 2 of the 4 down. Here we go. In your next lecture, and this is just a preview, you will learn about what are known as constructor functions. To sum it up, a constructor function is just a function that returns an object. Now, where do you see the word return? Nowhere. That's right. So if I run this function, if I use the keyword new, and I prepend person, and I invoke it, it will set this attribute, these attributes, to this person. So if I look at const Andy equals to new person, very much like person.new in Ruby. I take a look at the Andy object. It is actually a person object with name and favorite color. Name and favorite color. As I pass it in. So far, so good. All right, you will get much deeper dive on constructor functions and classes in the next lecture. If I take type of Andy, it's just a plain old JavaScript object, a POJO, if you will. Don't like that very much. So far, so good. When I talk about this keyword in the context of a constructor function, I'm adding these attributes almost like, not exactly, instance variables. So if I do Andy.name, I get the string Andy, or if I do Andy.favorite color, I'm going to get red. So far, so good? All right, so this keyword in constructor functions, Siobhan will go much deeper into. Just want to let you know that the constructor function changes the behavior of this. So let's talk about this keyword. And there are three important meta-programming functions called apply, call, and bind, call, and apply. That's the order I like to say them in. I have person one. The name is Andy. This is how your app can scale. If I run a function called sayName, I pass it a location and a time, I can run this function. And what do you think this .name will be? Just blanket.
Window.
All right, let's do it. Can you see the side? Is it cool? Is it Gucci, Gucci, Gucci gang? All right, what does sayName? What is sayName?
Function.
Right? If I pass it in with a location like New York, I don't know why we say it like this, but it's New York. The R just goes away. And the time is now. What would be the return of this function? What does this .name become?
The Twitter.com/Dan.com.
Those are all really good guesses. That's a very good guess. What type of function is this? Let's think back to rule number 4.
This is the one.
It's a baseless function, which means that this, in a baseless function, not being called on any object in particular, this becomes the window, which, if I interpolate, what is window.name? That's what it will become. I want to let you know that, for whatever reason, in all the wisdom and glory of Google, this .name is actually technically an empty string by default. So we can take a look, and we can see, what is this? Oops, embarrassing. Oh, the window, wow. This .name, empty string. So I can set this .name is equal to Mr. Powerful, wow, smiley face. So if I run sayName, I didn't actually run that function. Ugh, embarrassing. sayName, boop, boop, and I pass in here, and I pass in now. What will I see?
Mr. Powerful, wow.
Cool. Does this particular function scale? It's a weird question, right?
No.
It's a weird question. Like, I don't really even know what I'm trying to I do know what I'm trying to ask, but you don't really know what I'm like even trying to say. The idea is that this function can't scale because I can't set the this keyword. Right? If I can change the this keyword on the fly, that would be powerful. That would allow me to scale this function. To scale the sayName function. Right? There is a way. What do I really want? I want this to have a property of name. Luckily for you, I have given you random objects that have, oh, would you look at that, name properties. So far, so good. There has to be a way that I can tell say name, pass it person 1, and set person 1 as the this keyword. So if person 1 is the this keyword, and I do this dot name, what do I get?
Andy.
Right? So I want to set the this keyword. Well, let's look. Here's where bind, call, and apply come in. If I were to attempt to do apply will do this. It will invoke and bind the function. Binding just means that I'm going to force what this keyword is going to be. So, apply. How many arguments does apply take? 2. How many arguments does say name take? 2. So, apply, if you look, New York and 5 p.m. If the function that I want to force this keyword to be has to be the first argument. So when I do say name.apply, I'm saying I want say name, and I want to apply person 2 to be the this keyword. And therefore, say name takes how many arguments? 2. I have to give it an array of all the arguments afterwards. All right, call's super easy. Say name.call, I'm going to force person 1 to be the this keyword. And say name takes 2 arguments, so I'm just going to give it 2 arguments. The only reason call and apply exists is what if your function takes 6 or 7 arguments? It's easier to just give it an array of arguments than rather person 1, argument 2, argument 3, argument 4, argument 5, argument 6, argument 7. That's the only difference. Call takes every single individual argument, and apply will take an array of all the arguments the original function is looking for. So let's actually put this
Is
into
that really the difference? Just the array?
That's it. And so let's put this into practice. If I say person 2 will be the this keyword, what will I see if I pass in New York and 5 p.m. to the say name function? If I apply person 2 to be the this keyword.
Andy says hello from
Person 2.
Oh, John.
Huh. Oh. Bloop, bloop. It says John says hello from New York at 5 p.m. Cool. What if I did the exact same thing, but then I put in person 3? Whoops, that's not right. Oh, dang it. Dang you. Bless up Chrome DevTools. Gary. Because person 3 is Gary. It is just forcing this keyword. Notice when I ran sayname.apply, what returned?
First undefined.
This is like a console log thing. It's stupid.
Okay.
A string return, right? It is the actual return value of the function, which is a string. Which means that apply will not only force this keyword, but it will also immediately invoke. Right? I binding person 3, I'm forcing it, and it will also invoke. So far, so good. How do we feel about call and apply? Right? Pretty good. Let's talk about bind. Bind. Bind is very interesting. If I do, say name.bind, look what actually comes up. Let me clear this. What is the return? What does that fancy F tell you? Function. Is the function changed?
Yeah, I think this is now person 3.
The function, as it's written, has not changed. However, I have binded person 3 to be this. So it doesn't actually change textually, just contextually. Before I binded it, this was what?
Window.
But now that I've binded person 3, this is now person 3. So, if it returns a function, notice it did not invoke it. The thing I have to do actually is I have to set it to a variable in order to have a reference to it. So if I now look at bound person 3, notice that this keyword is still written there. This is a function, so naturally I can just invoke it.
So I have a question. So we can't just put like say name dot find person 3 in parentheses and then call it immediately? Like that's not an option?
Yeah, you remember this returns a function, so you can in fact drop some bananas there and invoke it immediately. But the real use for this is that it bind returns a function.
It's a new function.
Yes, versus call and apply, which will invoke immediately. So, call will invoke and bind a function. Does that make sense to you? Now, apply will invoke and bind the function. Right? The only difference is all the arguments versus an array of arguments. Now, bind will set the value of this, but does not invoke. Does that make sense?
So in terms of when we did bind, if we still called say name would technically, it would still be the window, it would be called. It's basically 2 different functions.
It is 2 different functions. If I,
This is. Okay.
it will return a new function. Here's
Because of the context.
they are different functions. All right, if I compare them, they will be different. Even though, if we look at bound person 3, and we see say name, they look the same. But they are in fact not. So bind will return a new function with this keyword bound to the argument. Sorry, when I say things and I was like, oh, that was kind of abstract. It made sense to me, but I only care if it made sense to you.
So it's like you're making bound person 3 is like you're making it the window. Right?
I'm making the argument to bind this keyword for that function. Cool? Let's see how this could be potentially useful. All right, so we're good on all the rules. All right, let's talk about the arrow function. This is heavy. All right. First, let me actually just write out the main differences in terms of like what the syntax looks like. Function, not arrow, bananas, curly braces, curly boys, right? I can do not arrow. How do I do it? How do I make a arrow function? Well, I can just go whoop.
Parentheses, arrow.
Yes. This is the only difference. If you want it to be even clearer, let's get crazy. Wow. All right. It's just where this bad boy is versus the keyword function. How do we feel about the syntax between function keyword and the arrow function? Should be easy breezy, right? Now, I'm going to say something, and hopefully you will understand. The arrow function will bind this keyword. All I'm saying is something with the arrow function will do what?
It's automatically going to bind the keyword.
it's going to bind the this keyword, which in abstract, it don't make no sense, right? Let's see it in action. I'm gonna have const arrow. Cool. This arrow is just an object that has one key on it. That one key returns a function, and it just returns this. If I invoke it, what is the this keyword?
Window.
Yeah, it's the window. Like, which is weird, right? Because what did I show you before?
That when it was the method, it would be what the method was being called on.
Oh, now I'm getting crazy. All right. I could do const dog. We'll do this. We will write this example. And I can have say this as well. But this time, it is not an arrow function. It will be the keyword function. The keyword function and the arrow function. Say this, keyword function. Say this with the arrow function syntax. So if I do dog dot say this, I get what?
Dog. That technically would be the dog object right there.
Oh yeah, that's actually, yeah, that is actually correct. This is the dog object. Ooh, it has a key and value. Ooh, thank you. This is the dog object, right? It's just one key value. Versus the exact same thing with the arrow function. And it returned the window. Here's what's happening. The function keyword will create its own context of execution, right? You can follow the dot operator and be like, this dog object is calling this method. The dog object is calling say this, being invoked. This is the keyword, dog. When I use the arrow function, you can think of it as a very loose inheritance. When I say it binds this, what was the this for the this arrow object?
Window.
When I look at this arrow, what is the this keyword for it?
The window.
It's the window. So this arrow function took the this keyword from this arrow, which at that time was the window. It's very hard to follow, and a better example is coming. I
So
just
it's
want to
always-
explain what's happening.
So it's always going to be the window, it's always going to be the function one
It-
level up.
You can think of it in that way, but it's not perfect. All right, that's just conceptually what's happening. So you can already see there is going to be a difference between the arrow and the function keyword. So all these examples are so stupid. If I run cook food, what will this be? Guesses?
It's gonna be the window.
Right. Undefined is cooking undefined. Which makes sense, right? Food item, I'm not even passing a food item. I could just, but, right? That makes sense, right? Like food item is an argument being passed in. Food item goes to food item. Nothing, which is undefined, whereas the lamb sauce is being passed in as a food item. That's good so far, right? The undefined is where the tricky part is. If I wrote this with the function keyword, what would the value of this be?
Chef Gordon Ramsay.
This is technically going to be the object
yeah.
that calls it. So chef name on angry chef will actually give me the string. Still fuzzy, right? But slightly better. Still fuzzy, but slightly better. Let's do one more, and this is where it gets wild. where it gets real wild. Oh man. All right. Ah, so cute. All right. Let me explain this code. Ooh, embarrassing. So, dog, function keyword, right? I use the function keyword. What is this? Dog. So dog.faveSnacks would be an
Array.
array. So far, so good. I'm calling a dot for each on it. So far, so good. I can call for each on an array. No big deal. This takes a callback with what type of function?
Arrow.
Which means that it has binded the word this. For each, the this for each is
The dog.
dog. The this for each is the dog. So if that's the case, this dot name is what?
Still the dog.
Still the dog. Winfield. Arrow function. We're going to go through a lot of wild examples, and I'm going to try my best to clarify.
You need to refresh the page.
That's fine, I said it already. Cool. So dog.eatSnacks. So far, so good. Boop, boop. Wow. Chrome DevTools. They sent an update. All right, here we go. They sent an update. Here we go. I'll play your game. I'll play your game. Here we go. Wow, that was very silly. There we go. All right, now I have to run the JavaScript now. Index.js. Cool, I'll just put it in the body. I'll just put it in the body. All right, here we go. Open index.js. HTML. Embarrassing. Cool. Dog. The Twitter doesn't allow you to run JavaScript the same. They block a lot of things. Either way, don't worry about that. Are we? Sorry for the hiccup. Are we cool? All right. What's up? Oh, thumbs up. Cool. So let's take a look at this code side by side. So this keyword is very danger. It's very hard to understand, but it is very important. So, function keyword, let's do this. Comma, eat, snacks, all, function. Okay? All I'm going to do is function keyword, boop, boop. I'm just going to recreate the same thing. This dot fave snacks dot for each. And I'm just going to pass it in a function keyword callback this time. And it's just going to do the same thing. Look up. So far, so good. So, dog.eatSnacks, boom, boom. Dog.eat snacks all. Oops, sorry, that's embarrassing. I got it. What is happening here?
It's now the window. What is this?
Allow me to explain. Watch the refactor. You ready? I'm going to space it out. Remember, the JavaScript is space agnostic. I didn't do anything. I just moved the function into its own space, right? Watch the master at work. Did I do anything crazy? All right. Okay. Yeah? That's all I did. Ready? Here we go. Line for line, exactly the same. Right? So, let's do this. This is where people lose their minds for some reason. Is this line for line the exact same code?
No. One's anonymous and one's not.
One's anonymous, one's not. But it's basically the exact same code. Right? If I just put some callback in here. Let's do this. Put them next to each other. Is that okay? Oh, the annotate is killing me. So how happens when you write good, clean JavaScript? All right. This function is an anonymous function that I have defined in line. Does that make sense? This is the exact same function that I have defined out of scope that I'm then just going to pass in. This has this right here, and this does not. That's where people lose their minds, right? You're like, well, how does it know to get this back? Right? Or no, or we know.
Yeah. How does it do the same?
Correct. This is where people lose it. I need you to trust me on this journey, and then I will spell it out. This is a function that I've defined in mind. Did I invoke this function? On 16, are there bananas? No, this is actually a function I've defined in line, which means that this is in fact a reference to a function. This is just a function definition. This, line 17, is in fact just a function definition. This is not being invoked. The anonymous function on 14 is not being invoked. And line 17, this callback is not being invoked on these lines. Yes or no? Okay, so I cannot and should not, do the add bananas. I shouldn't do that because that would mean this also gets invoked, which is not the case. How do we feel so far about 14 and 17? Are they the same, yes or no? I will explain how it's getting snagged in a little bit. I just need you to trust me that it's going to get it. Are there any differences?
The context, where it's getting this from?
Yes, and I've defined it in line, and I've just extracted it. I would say that 14 and 16 and 17 are exactly the same. I would say they're exactly the same. Which means that line 24 is in fact a baseless function. Yes or no? 24 baseless function, yes or no? Where is line 20? This is my fault. Where is line 24 being defined? Justine?
Global scope.
Exactly. Line 24 is being defined on the global scope. This is a baseless function, which means this on a baseless function is
The window.
the window. So in the for each, I'm just going to invoke what you can see as essentially a baseless function. Boom, boom, boom. Right? If this is a baseless function, then of course, when I invoke eat snacks all function, the window.name is undefined, empty string. Is there a way I can force what this keyword is? I can bind it. You following me? I can bind it. I can force what this keyword is. So I'm going to leave this in here as is because for whatever reason, it just seems, it seems easier for all of you. So far, so good. Okay. In the for each, I want to bind this function. And what do I want to bind? What do I want to force the this keyword to be? So far, so good. That wasn't bad, right? How was that logical leap? One more time. Without the bind, this anonymous function is technically a baseless function, which means that the window is what the this keyword is. I want to force the this keyword to be something. And so I'm going to force this function to have dog. I'm going to bound the this keyword to dog. That way this dot name becomes dog dot name.
Could we hypothetically bind it to something that's outside of this function? Like if there was.
I can bind it to anything, yeah. I can bind it to an object that has name as a keyword of your boy. So what would the this keyword be if I binded this to this object?
It'd be that object.
It'd be that object, right? Which means that this dot name would be, so your boy is eating cabbage. Your boy is eating carrots and bones. I don't actually eat those things, but how are we feeling about binding an object, right? And so instead of binding your boy, I passed in dog because what we're looking for is name. I'm gonna save. I'm running dangerously low on battery, and now it's working. If I Yo, do you mind grabbing me a charger real quick? Thank you. How are we feeling about bind? Better? Useful? Let's think about a couple things here. This is where the brain buster is. Okay. Dot bind. What is the scope of this keyword here? In the same way,
It's the dog.
bless you. In the same way the scope of self was here. Thank you so much. What is the scope of this keyword? So here self inside the scope of the class was person. Inside the scope of here, lines 3 through 19, what is the scope of this?
Dog.
Whoa.
Ruh-roh. Is it dog? How are we feeling about that? The scope of this keyword between 3 and 19. So right now I have dog. We also said within the scope here, this is dog. Well, if what you're saying is correct and this is true, line 19 is true, then what's the difference? The brain buster, right? How do you feel about bind? So when I say I'll say it again, exactly the same way. When I say the arrow function will bind this, does that make sense? That is the hardest thing really to teach. So if it's like kind of fuzzy, I promise you, this is actually a pretty decent explanation. The arrow function will bind this. Does that sentence make sense to you?
Yes.
Okay. Remember, that's one of the two parts I need you to take away from this lecture. The arrow function will bind this.
And this is wherever the arrow function is written, whether it be the window or, in this case, inside the dog object.
The other part of this lecture that I said was important was understanding Dan Abramov's question. which is a bit dicey. Object.method, var method equals object.method. This is part 2 to it. Let's put this into practice. So I'm going to try to copy that code word for word, line for line. All right, so what I'm going to have is, you guys like, what kind of animals do you like? Is dog okay?
Dog's good.
Okay, all right. It's equal to an object, right? So, right? And I'm just going to put this. I have to interpolate it. Ugh. Dang it. Let's do this. Name, what's his name?
Sealy.
All right, ready? Seals can kiss. And this function just, yes. Sealy, very good. Just dot name. All right. Okay, just kidding, I messed up. So far, so good. Nothing crazy, right? So what we're talking about is line number 1 from Dan Abramoff, and that is object.method. Boop. And then on line 2, we have some method. Var, just kidding. Blah. Whatever. Equals to seal.kiss. Did I do anything different? Right? This is being invoked on line 30. I'm simply saying some method is equal to object seal dot method, which is kiss, and that is not being invoked, so that I can store the function into the method, not the return value. Right? So method is in fact a object. So if I were to console log some method, it's in fact interesting. Remember, functions are what type of data structure in JavaScript?
Objects.
They're objects, and objects are passed by reference. If I do some method and I triple equal seal.kiss, what do I get? Look what's happening. This is the object pointing to the same object in memory. This is just a reference because objects are passed by reference. This is why day 1 is important. Some method is a function. Seal.kiss is a method. They are in fact the same. Seal.kiss, if I invoke it, gives me what?
Sealy for rows.
If I invoke some method, what do I get?
Cover rows. Sealy for rows.
True. Different.
I have to call it on something.
Kiss is a method being invoked on an object. Some method is being invoked on the, so self, right? Where I write it is important. When I execute it makes no difference. It's always going to be me. This, however, where I write it, this goes here, this goes here. Where I write it is important. And when I invoke it. Specifically how? If I invoke the exact same method on an object, and when I invoke some method on the global, on the window object, it changes the return value. So this is impacted by 2 things: the context execution and when it is invoked, right? Where I write it and when I call it, the this keyword will change. So this and self are not the same. This and self are not the same, yeah? This will change based on when I called it, right? Like for example, this water has no fruit in it. How bland, right? But this board is very big and I'm not used to it. When I say it, what I'm referring to will change it. This, when being called on an object, will be the object. This, being invoked as a baseless function, will be the window. I know, this is tricky stuff. Didn't like that. All right. How do we feel?
Can you compare those some method, invoke it, and compare it with CLKISS and invoke it? Would that still be true or false?
If I invoke some method, bananas, and I invoke bananas here, I'm then comparing string to string.
It's false.
And string to string as values will be false.
So when it's true, it just means that the recipe that these two contain, like
The function, yes.
Yeah,
You said
they're the
recipe.
same, but
Yeah, yeah.
then when you invoke it, the return values are different.
The point I'm trying to make is when and how you invoke it will have an impact on the this keyword. That's really the only point I'm trying to make. How do we feel about that point? So, we talked about the two things that we need to know. And one of them being, do you understand why these are different? Congratulations, you know JavaScript. Thank you. That's all I have for today, actually.